Yeah.
Regular Huygendorf is called Gilpandi in Korean.
Gilpandi.
Gilpandi.
Yeah.
They live in the sand at the bottom of shallow waters, and they become active and eat food at night. Second, when can we see the light? Regular Huygendorf has a substrate and the enzyme. This is the substrate. And this is the enzyme.
Yeah.
When they react them with oxygen inside the water, it emits light. It emits beautiful blue light.
Yeah.
Don't you want to see the Huygendorf emit light? I'll show you again. This is a movie of the Huygendorf emitting light. You can see the light at the moment we put water in it.
Yeah.
Then I explain our purpose. Our purpose is to find an effective method to maintain their luminescence. We set some goals. First, we want to identify the optimum conditions for their luminescence.
Yeah.
Second, we want to quantify the luminescence.
Next, we'll explain previous experimental method.
Okay.
First, we made dried body Huygendorf and used it as sample. And this is our experimental equipment.
Yeah.
We put sample in test tube and we put water in it. Then it emits light. We record the luminescence time
Yeah.
and we take the picture of it lighting.
Yeah.
And next, how to search for the peak of the lighting intensity. We set the peak of the lighting intensity by using a computer software called Macari. Yes, Macari. This computer software is used by astronomy researchers. And when we took the picture, we saved the data as raw data. What is raw data?
What?
Look at pictures.
Right.
Right.
The right picture
Yeah.
is clearer than the left pictures. Do you understand?
Yeah.
Light is clearer. Raw data is a way to save the data without reducing the information. So we can get an accurate data by using raw data. And in order to analyze, we change the raw data to fixed data. This is a picture of the software being used. Look at the left picture. We drew a line. And then we get the graph like left picture. We repeat these draw lines and get the graphs. Repeated this and we search for the peak of the lighting intensity.
Okay.
Number 6. So, what was our failure? there were two big failures in our study. First, we did not set the camera setting correct, so we got the wrong data. Second, we obtained bad quality dry Bardola-Hilden-Dörfy samples from our previous method. From this blue graph, you can see that almost in every temperature, we got a similar maximum luminescence data. Look at the maximum luminescence data for 2 degrees Celsius.
Yes.
This data shows that the maximum luminescence for 2 degrees Celsius was much smaller than the rest of the temperature. Actually, we used a different sample for 2 degrees Celsius, and this shows that we could not obtain good quality samples. How did we fix it? We fix it in 2 ways. First, we adjust the setting of the digital camera we used. This way, we could measure the peak of the intensity properly. Second, we changed the way of making the samples from ordinary dried samples to freeze-dry ones. Freeze-dry can prevent it from decreasing luminance power, so we could obtain good quality samples. Number 8, prospects from correction. We were able to quantify the luminescence intensity using our analysis method. However, we were not able to find the optimal luminescence conditions. So, we would like to change and establish the sample preparation method first. Then, we would like to continue the experiment. Lastly, these are the references. 감사합니다.
네, 감사합니다.